But I was at REI for 27 years, oversaw research and testing, product quality, helped re-engineer the private brand group, and had a number of different roles. When you're there for that long, you have lots of opportunity to do a lot of different things. But it was at REI that it became evident the work that we were doing in producing and bringing product to market, designing, creating, purchasing from wholesale brands. We were making an enormous amount of impact on the planet, and so it was an opportunity to get the industry to work together. And so it was actually that which was the impetus to actually create what became the outdoor industry work group on sustainability. And it was a great position because REI, being a pretty sizable force in the industry, and we wanted to talk about sustainability, and you got your CEO to come along with you, it was actually quite easy to have that conversation, at least to get the conversation started. So I did that for a number of years, and then an opportunity came up for me to not just work for one brand, but to work with many brands. And that's what I do today. I work for a company called bluesign. Is anyone familiar with bluesign? Raise your hand if you've even heard of bluesign before.
Have you seen it on a hang tag, perhaps? Or
I've seen it on a hang tag or whatever.
Yeah.
It's not an incredibly consumer-facing instrument yet. We're growing. I mean, it'll be interesting when I actually go through the presentation. You'll be able to see a lot more about who's using bluesign and where does it fit into the picture. But and I'll get into a little bit more about what bluesign is in a little bit. But my role at bluesign is to actually work with brands, and so I we have brands all over the world. We have about 85 brands that are part of our organization, and it is really the who's who of brands in the sustainability space. A lot of outdoor, but not just outdoor. And it's an opportunity to help them understand where they are in their trajectory on, I say, chemical integrity. It's hard to differentiate with chemistry and other impacts that would be falling into the sustainability, including social as well. We'll talk about a little bit about that. And so I work with them to help them understand where they are and help them chart a path forward. And when you're working with a brand that is well established in sustainability, like an REI or a Patagonia, the work we do is different from someone who's just starting their journey. And so I was actually at a brand last week in San Francisco that really is just getting started. And so it's great to be able to roll up your sleeves and get started. So I have to interject a few pictures. It really stinks living here in Sisters, let me tell you. This is a picture taken last winter at the top of Santiam Pass. Amazing how little skiing people were around skiing this year, but that's Mount Washington there. So we talked a little bit about me, so we can move on beyond me here. We're going to talk a bit about chemistry in the network, but I want to start with I love this quote. This is one of my favorite quotes, because whenever I get a chance to talk about sustainability or environmental impact and stuff like that, and this isn't self-deprecation, I really feel like an environmental idiot, because every time that I learn something, I realize what I don't know. And this quote just really sums it up. We are absolutely surrounded by a sea of ignorance. We are on an island and every time we learn more, our shore of ignorance grows. And this is a really important thing as we go down this path, because there's so much to learn. And the work that Beth mentioned when we started with the outdoor industry a long time ago in this sustainability. Our island has grown, but we've also learned so much about what we haven't really been able to address yet. So when you look at the impact, and just look at the volume of materials that are being produced on an annual basis, I wanted to kind of just put things into perspective here. What this is telling us is not only are we using a lot of textiles, aren't we creating so much textile, but the fact is that the amount of textile per capita, per person, continues to grow. So it isn't just that the population's getting more, we're using more per person, and that's quite concerning, because the amounts and the impacts that creates is pretty significant. In fact, just for purposes of perspective, if you consider that on an annual basis, we're creating enough textile to cover the entire state of California. And this is actually a little bit old. I would bet we're beginning to approach Klamath Falls in southern Oregon now, and then soon we'll be covering Bend. But the point is that every year we are generating so much textile on the planet, and with that comes a lot of impact. What kind of impact? I mean, there's been a number of studies on how much impact from a carbon perspective. I know that some part of your reading and some of your information is really talking about the carbon footprint. It's been debated for quite some time. One of the most recent studies puts it around 2 to 3%. It's been described as being almost 10% of the climate impact in the world is attributed to textiles and apparel and footwear and products like that. We don't know, the data is unclear, but we do know it's significant. But similarly, there's other impacts as well. Water is oftentimes, when we're producing textiles, we're doing it in a water scarce part of the world. It requires a tremendous amount of water to produce textiles. And then we're going to dive a little deeper into chemistry. This blows me away. 15,000 new chemicals registered every single day. Yet our processes of bringing chemistry to the market is insufficient to talk about hazard, risk, the things that you would think would be common practice. They're not. And then when you look at chemistry just for the world of textiles, there's an enormous amount of chemistry necessary to bring textiles to market. And this last point is really, it kills me to say that still to this day, we still see a lot of the chemistry, this is talking about dye stuff, which is being released directly to the environment from the textile mill without any water treatment whatsoever. And so this is not what was happening years ago. It still is being done today. So I lived through a number of different challenges when I was working at REI on water repellency and bisphenol A and a number of chemicals. And one of the things that we have to be really careful when we talk about chemistry is that just because we're moving out of a chemistry, just because we say a chemistry is not something we want to have in our product or our supply chain, doesn't mean the alternatives are good. And so we want to be careful that we do what we call regrettable substitution. And so as we go down the path of learning more about chemistry, it's not about what you're learning, what you're getting out of. It's also learning what you're getting into as well. And so this is really important, and we'll talk a bit about this as we cover a little more about this in the future. But I used to get these questions all the time. Are there any chemicals in your product? Because you know what, I don't want a product with any chemicals in it. And my response was always the same. You're gonna be naked, because there is no option that doesn't have chemistry. Even some of the best, most organic product requires chemistry. Water is a chemical when you really come down to it. I mean, it is salts which are necessary are chemistry. So it's not about chemistry being a problem. It's chemistry often is a solution, but bad chemistry really is a problem, and we need to work on eliminating that. And so what does it cause? It causes a risk. It causes, really being clinical about it from a brand perspective. You can be non-compliant with a regulation, or it could be an industry standard or expectation, or a rapidly changing market. A good example is bisphenol A, or BPA. It was never actually regulated out. I mean, it was in some little jurisdictions here in San Francisco and a few other places, but for the most part, it hasn't been regulated out. But the market changed. You could not sell something. You couldn't sell a polycarbonate water bottle that had, bisphenol A in it, or BPA, anymore, because the market had changed. So you have to be aware of that and be ahead of that. Clearly, brand reputational damage with bad chemistry. But a lot of this is also really about good business practices, because you can really disrupt your supply chain if you're not paying attention and have chemistry in there that you really don't want to have as a part of it, because a whole host of reasons it just can interrupt your flow of product. Clearly disconnected with your brand's values. Your employees, more and more are very much concerned about what your organizational values are, and are you consistent with that? And then more and more for publicly traded companies, the investment community is paying a lot of attention to how brands and how companies are being way more responsible. Chemistry is another one of those spaces. So you get retailers, you get brands. When I was at REI, we were both. We were a strong retailer that had a pretty sizable private brand, and some brands obviously have a lot of retail. North Face has a lot of stores, but they're primarily thought of as a brand. Pretty straightforward. Tier 1, think of this as where finished goods come together. This is where the product takes its final shape before it's put into the marketplace. And you notice also, it's not just that you have a factory building it. Oftentimes you have a lot of subcontracting going on, laundry to printing to you could have a whole bunch of embellishments, or even subcontracting the entire production when they don't have enough production volume in that particular facility. So that's tier 1. Tier 2 is where materials come together. So the output from tier 2 is a finished material. What comes in might be a yarn, or a plastic pellet, or something, a metal part, or a metal feedstock. But out of it comes a finished material that can go into tier 1 to become the finished product. And there's many stages in tier 2, from weaving, knitting, molding, forming, to dyeing, printing, coating, finishing, lamination. There's a lot going on there. And by the way, yes, there's also a fair amount of subcontracting that goes on there as well. Something that brands don't often really think about is subcontracting at tier 2. Tier 3 is where materials really begin to take their shape, coming from the raw stock to becoming a yarn, becoming a pellet in a polymer, or a tape, or down might be being processed to actually be ready to be injected into a jacket, or into a sleeping bag, or what have you. So tier 3 is a very important stage. It's a very intermediate stage in the process of bringing product to market. Tier 4 is where raw materials come from. So it could be any types of raw material. It could be farming, it could be agriculture, it could be, as in cotton, it could be livestock, as in sheep. It could be extractive industries, from oils to natural gas to ores. But also consider that tier 4 is where, when you talk about recycled, it comes back into the process and gets either ground down, completely repolymerized, to produced in a different way. So we'll remember that, because that'll come back to us a little bit later. So there's a couple of gaps in here they want to fill in really quickly. One is what we call agents, trading companies, or licensees. And these are all different things, but they fall at the same place in the network. Sometimes brands use these, sometimes they don't. But when they do, they say, okay, I may have an idea for a product, but I don't really know how to make it. And I don't know who's going to make it. And so I reach out to a trading company, and they have that network relationship, and they actually drive that. Sometimes a brand says, I've got a really great product, I've got a great market, except I'm not really good in this particular market. So I get a licensee. For example, the classic one I always use is when you go to Korea to buy a product and you want to buy a North Face jacket, you're not buying it from North Face. You're buying it from another company that has the North Face license in Korea. So this is not uncommon. I think North Face would love to get that back, but that happened many, many years ago. And it's just a natural part of the way some networks work.
It's called Goldwyn, by the way, if you're ever in Japan.
Yep.
That's the name of their distributor in Japan. They make great product you can't get anywhere else. You can only get it in Japan because they have a different side note. They have a different product development team.
For sure.
So,
and there's advantages to doing that. And there's also some challenges because you can lose some control.
Yeah, absolutely. Absolutely.
Yeah, I mean, if they decide to do something, I remember being actually in Korea and sending a picture to my friend at North Face at the time of a picture of a box of tissues. It was the red North Face cube, and I took a picture of it and sent it to her. This was Letitia when she was at North Face, and I said, "Never stop sneezing."
Nice. I hadn't heard that story. That's great.
Yeah.
Anyway,
So another important part of the layer is what we refer to as converters. And so converters are an integral part of the network that oftentimes people don't know are there, because a brand may think of them as a material supplier. They may go to the OR show and they visit a booth and they say, oh, cool, this is really nice material. I like this. Can you get this, or can we do this to it? Can we tweak it this way? And they say, oh yeah, fine, we can do that. And they get price quotes and you develop a relationship, and fantastic. When you go to actually visit the mill, it happens to be somebody else, because it's not actually the company. The converter is really just an office. And what they have is relationships. And so it's not a bad thing. In fact, there's some really excellent converters that sell into the market. The challenge is that when you can think from a perspective of sustainability, both converters but also trading companies can be an enabler for sustainability, or they can be an impediment, because if it's not a lot of transparency, it doesn't exist. So where Matt got really special with this diagram was talking about chemistry. And what he did is he said, chemistry is not tier 5. Chemistry is actually a separate network that feeds into it. Because when you talk about chemistry at tier 1, a laundry or a printer or something that actually uses a fair amount of chemistry, most cut and sew doesn't uses some, but not much chemistry at all. But some organizations use a lot of chemistry. And so that's the specific chemistry used at tier 1. Tier 2 is a huge amount of chemistry. It's dyes, it's laminations, it's solvents, it's a tremendous amount of lubricants and what have you that is necessary, and what we call auxiliaries in the whole process. Tier 3, also a fair amount of chemistry. And tier 4, it could be very different chemistry. If you're talking agriculture, it could be pesticides, it could be fertilizers, it could be a whole host of other things as well. So chemistry feeds into the network in a separate network unto itself. And the top layer of chemistry we call it a chemical company, but oftentimes it might be a converter. It might be a company that knows how to make chemistry, but they don't actually have the chemical facilities, and they work with others to make chemistry. And the next layer down isn't even making molecules either. All they're doing is blending. and it's an important part of the network. I don't want to belittle it, but they're taking molecules that already exist in the market and they're blending them, and they may be getting their direction from a converter, or they themselves have an idea for a recipe that they're producing for chemistry. We don't get to an actual new molecule creation until we're 3 layers deep into the network of chemistry. And that's where we refer to as synthesis occurs, where you have new molecules being created. It's kind of like in your high school chemistry class where you added this substance and a little fire and heat, and you come up with a third substance. That's synthesis. And that's a good portion of where the real challenges of chemistry actually exist. And then way upstream is what is the large petrochemical companies. So we know them as ExxonMobil or British Petroleum. They're not only are they producing stuff for your car, they're producing a lot of petrochemicals that become feedstock that actually ultimately show up. And there's a lot of companies in there that you've never heard of before that are in the petrochemical business. So this is it. This is the oversimplified view of the network. And it's important when we talk about chemistry and we talk about impact, because where that occurs is really, really important. So see if we're paying attention here. So we're talking about a typical tier 2 textile manufacturing. There's only 3 inputs to a tier 2 manufacturer. It's material, water, and energy. Chemistry is just another material. So think of it as another material. It could be a fiber, but it could also be a lot of chemistry that comes into a textile manufacturing facility. And so in this particular facility, we're producing fabric. So a bulk roll of fabric comes out as a product. However, it's not the only thing that comes out of that facility. What also comes out of that facility is waste material. Also waste water, a tremendous amount of waste water. And then also, you may not always see it, but there's a tremendous amount of air emission that comes out of that facility. So here's a number to remember. When you look at all the chemicals that come into that textile facility, and let's just pick cotton as an example. We could use polyester, but they won't be too different here. But let's just take cotton as an example. Of all the chemistry that comes into that facility to produce cotton, of the chemistry that comes out with that bulk roll of materials, only about 10% is going to be associated with that bulk roll of materials. So 90% of the chemicals that came into that facility are not going out with a bulk roll of fabric. They're going out either as an air emission or a water emission or waste. And because so many of those chemicals we know to be quite challenging in their toxicity and their impacts, it's really important we're paying attention to what's going on there and managing that really carefully. So when you look at chemistries, if you've ever been into a facility, or if you've ever seen the blue barrel of chemicals in a facility, you say, great, it's a chemical. It's going into a product. The reality is, what goes into a product is not a single chemical. It's a mixture of chemicals. In fact, there may be multiple barrels that go into the cocktail, that go into the production of that particular fiber or material. And that is made up of a bunch of what we refer to as intermediates. So it starts getting complicated really, really quickly. And then if you break down one of those intermediates, you can have intended substances. It's a water repellent, okay? It's an intended performance molecule. And then along with that molecule are additives to help that molecule do its job. And then along with those intended substances and those additives are what we refer to as byproducts and impurities, because it's rare that you ever have a synthesis of a chemical and you have 100% reaction and it converts to a completely different molecule. Usually there's waste product that comes along with it, and those can create impurities. It's often those impurities that get us into the most trouble, because it's chemical companies that are good at making chemicals that can really manage that really closely. When you look at a chemical company, oftentimes they're not just making for the apparel industry, they're making for oil and gas, forestry, farming, agriculture. And some of the chemicals that we have defined in the textile world to say that shouldn't be there for textiles, it's actually specified as a particular chemical used in, for example, the truth is, one of the chemistries that we have worked very hard to eliminate from textiles, a category called APEO, is a specified additive for fracking. So it's like we're managing it to parts per million in textiles, and they're using it by tonnage in fracking. And so it's complicated. We want to make sure that chemical companies that we work with are really good at their game. So if we're dealing with this really carefully, we know that they are managing it well. And there's a lot of really, really good chemical companies in the world. We actually get to work with a lot of them. Many of them realize that bluesign is actually kind of the best way to do this analysis. So they really want to be a part of our organization. The unfortunate truth is that, and this is true for the outdoor industry, this is true for the apparel, general broad apparel industry, is that there's a lot of not very good ones, because chemicals tend to be a commodity. They're, when you talk about price pressure from a brand to a mill to produce a textile for managing it at pennies or fractions of pennies, what often gets squeezed is, how much am I going to spend on this chemistry? And so where you can cut down the cost as much as you can. And oftentimes, remember that diagram, chemical companies are really, really far upstream. And so making sure that you're paying attention to who's making the chemistry really matters. Why we're doing this here, clearly NGOs, appropriately so. I mean, we'll give credit to Greenpeace for kicking the outdoor industry in the butt on water repellent. More progress was made after Greenpeace really addressed the industry, because we hadn't been making progress on the issues of water repellency. We still have ways to go. There's some issues that Greenpeace hasn't even addressed yet. But clearly help from NGOs. I mean, you would hope for, and I believe that the outdoor industry in particular is proactive in addressing a lot of these things, but sometimes it takes a good NGO to keep the ball moving. Regulation, it's not slowing down. It is, in fact, it's speeding up. And organizations say, hey, I don't worry about that regulation because it affects Norway. We all are in the same global supply chain. And so recognizing, even if you may not sell in Norway, you're part of a supply chain that's producing product that ends up some in Norway, some in California, some in various parts of the world. So paying attention to regulations and being clear. In the US in particular, it's difficult, because we have a failure to address chemistry at a federal level. So the states take it on, and individual states will address it, whether it's Cal Prop 65 or what's happening in Oregon and Washington and a whole bunch of other states that are proactive in chemistry and addressing this and making it quite challenging for organizations, because they don't have to comply with one regulation, they have to comply with 50 regulations. And then there's the happy consumer, because you know what? If you're at a brand, they think you're on it. They absolutely think that you're taking care of it. Your chemistry, you're taking care of this. And most organizations can be deer in the headlights because it's really, really hard to do. And then I had mentioned that the investment community is definitely paying attention to where this is going. So what do you do about it? How do you address this challenge? Now that I've sufficiently laid out the fact that it's complicated and there's a lot of work to be done, there are some things that are way more effective than others. And I throw bluesign in the sea of other options out there. My marketing team hates this slide because they, oh, you share with all the other different options. Like, all of these have ways that they actually address it. And what's really important is understand how you solve the problem. Because solving the problem that is so complex and so far upstream and so opaque to so many brands really, really matters. Well, I managed quality, the quality function at REI for many years, over close to 2 decades, actually. And I can tell you, I never arrived at a quality product by looking at the end of the pipe, at the end of the production line, and say, okay, put an inspector here, look at every 100th product that comes off this line once a year, we'll be good to go. It doesn't work. It may give you some information, but it will not tell you, are you producing good quality product for the consumer? That's quality control. bluesign approaches this from a much different perspective. We're looking at quality assurance. Quality assurance is, how do you actually engineer the process better so that you don't have the problem to begin with? And in fact, that's what we did at REI. That is a quality program. It has both quality assurance and quality control. And similarly, in the world of chemistry, you cannot solve the problem at what we refer to as an end of the pipe solution. It just doesn't work. It's not going to be the effective way to address it. So we come up, as an industry, we come up with what we refer to as restricted substance list, or RSLs. And it's basically a brand saying to their supply chain, do not put these chemicals in my product. Well, you're sharing it with your manufacturer. They're not the ones who's making the chemistry. They're just applying chemistry. So when you look at where RSLs are being used, remember, you're here as a brand. The problem was likely created deep in the supply network, deep in the chemical network, way down here. The chemistry was applied somewhere in tier 3 to tier 2 to tier 1. A restricted substance list and a testing program to go along with that is a very permeable barrier that it's really hard to prevent that chemistry, that bad chemistry, from making it all the way to the consumer. So it's a tool. It's not without its merit, but it's not by itself going to solve the problem. So we got creative as an industry and said, we're going to come up with this thing called an MRSL, a manufacturer's restricted substance list. So we said, instead of testing materials, we're going to test chemicals. And chemicals, because if we eliminate the bad chemistry going into the network, we'll solve the problem. Well, it's wrought with the same challenges of testing. A chemical company that is out of control is not making the same chemistry in the morning that they're making in the afternoon. So how frequently are you testing this chemistry? Is it once a year? Is it every day? Is it every shipment? It really, really matters. And that can get extremely expensive, and in fact will not get it all. So MRSLs are, again, they're a useful tool used correctly, but by themselves will not solve the problem. So that leads me to the conversation of what is exactly bluesign. Beth wanted to tell you what the bluesign system is about. In a nutshell, well, first of all, we're about 700 system partners around the world. We'll get to what that means in a second. It's founded as a company. Is actually founded as a result of another failure in restricted substance testing. And a number of people got together, a company that makes material, Scholler Textile, a company that made chemicals, a Huntsman, working with a few brands, and they said, we need to really do a better way of doing this here. And what they did is they started the proactive system, of which became bluesign. It's now a private company. It was founded as a company in 2000. And we have, like I said, 700 system partners around the world, and offices. We're distributed all over the world. I mean, I'm in Sisters, but most of our people are based either in Switzerland, in Germany, in Hong Kong, in Taiwan, and very much in the supply chain, a big office in Shanghai as well. And we function as a system. Okay, and we have these relationships we refer to our system partners. System partners could be a chemical supplier, it could be a material manufacturer, or it could be a brand. And how we go about working with them is we start with chemicals. We start way upstream and we determine are chemical companies competent in making chemistry. And so we analyze once they've become a system partner, then the real work begins and we analyze their ability to make chemistry and everything about that, how they purchase materials, how they in fact test, how they manage the process, ensuring that those impurities are managed very, very tightly. Only when they are doing that does it become, and usually they're not competent enough at it, and there's some improvements that need to occur. In fact, upwards of 40% of the companies that try to become bluesign system partners, chemical companies, don't make it the first time. They actually fail for in most cases, what we refer to as product stewardship. And that's like the basics of making chemistry. Control their chemistry, control their impurities, control the being able to develop what's called a safety data sheet accurately. The good news is most companies correct their issues and they do become part of the bluesign system. We then look at the chemicals. What are they making? And we look at every single chemical, every formulation, and break it down into individual parts, and then determine are these okay? And in many cases, they may be in a violation of what we refer to as our bluesign black limits. This is kind of, I just talked about an MRSL a few minutes ago. This is kind of like an MRSL plus, and it allows us to really talk about what should be in this chemistry. So if it's a water repellent or it's a softener, what are all different combinations of chemicals that should be there? So we have a whole team of people that are just focused on managing that.
Hey, Kevin, can you just quickly explain what an RSL and an MSRL are for, in case folks aren't familiar?
Yeah, so I had a slide a little bit earlier, and it basically is, it's a list that has been created by a brand. An RSL, or restricted substance list, is a list created by a brand that says all these chemicals, all these substances, formaldehyde, a whole host of variety of different chemicals that shouldn't be in my products. It tells the network, tells their supplier, this should not be a part of my product. And an MRSL is the RSL is about material and product. An MRSL is about chemical formulation. So it's what's going into the network. So a materials manufacturer will use an MRSL to say, okay, chemical company, I'm producing for this brand here, and they don't want these chemicals in the materials I'm producing for them. Please make sure that these chemicals are not in the formulations that I'm buying from you, so that it does not show up in the finished material.
So and so a restricted substance list, or RSL, like Kevin said, is applied to the product. So that's something that a brand would have in-house for their products. Then the manufacturer's restricted substance list is, as Kevin was saying, a similar list, but that gets applied at the manufacturer level for the purposes of then selling to that brand. So, just wanted to clarify. RSLs have been around a long time. MRSLs are newer, right, in the marketplace, and that's been a newer sort of realization that, there was this gap before MRSLs existed, where it was sort of like, okay, brands are managing what's coming into their products, but if you don't, to Kevin's point earlier, if you don't try to start to address that, before the end of the pipe of the product, so to speak, then you're sort of losing the battle, right? Like you have to try to also work with your suppliers so that those things aren't coming into your product in the first place. So just a bit of background.
The challenge with an MRSL is that if a brand specifies it and says, okay, to my supply chain, if it's hard for them to determine if a material contains a chemical, because it requires testing, it requires the process of doing that work, it's even harder for them because they're one or two steps removed from that manufacturer of materials, because it's an input to the material manufacturer.
Yeah.
And so that makes it quite challenging. And as I just showed the diagram, and you may have converters in between, you may have trading companies, you may have a whole host of other things. You can start beginning to get the picture of how little a brand actually sees and knows about what's going on in their supply network.
Yeah. Yeah. That's a great explanation. Yeah.
Yeah.
Of why the MRSL is such an important piece of this as well. Yeah. Okay, great.
So moving on bluesign. So we do essentially the same thing with the manufacture of materials. Before we go in and say, what material are you making? We go in and say, how are you making that material? Because remember, 90% of that chemical, those chemistries, are not going to go out with that bulk roll of material. Most of them are going to go elsewhere. And many of those chemicals are quite challenging. And so how are you managing that? Are you buying, first of all, are you getting the better chemistry to begin with, but are you managing chemistry in the best possible way? And all the other inputs. And then there's lots of other environmental health and safety issues that are associated with using chemistry and producing textiles. In fact, most of the issues that we talk about when we talk about chemistry it's not a consumer issue. It's a worker issue. And so much of that happens at the manufacturing stage. So we look at everything. We look at their dye kitchen. We look at their processes of dyeing and finishing and all the printing and what have you to produce materials. And we look at their how they manage their air emissions, how they manage their water emissions. Are they doing a good job of that? And oftentimes the case is no. And ensuring that this is a high priority for them. So once we do that, we look at, okay, great. What are you going to make? You're making polyester. Fantastic. This is the chemical inventory that you need to make polyester. Share with us your chemical inventory, and we review chemical by chemical exactly what goes into making that polyester. And then where it's not good chemistry, it gets swapped out. Where if it's bluesign approved chemistry, it's a fast, happy path all the way through. So you can see, if you've ever seen a bluesign approved material, you don't just have better, you haven't met just simply an RSL. That everything upstream from that has been done appropriately and correctly. So it has that assurance all the way through. So you can see, you can do a test, you can do a restricted substance list test, but you're not going to find anything because it was prevented from ever being there. So we're looking for chemistry, for consumer safety, clearly, for worker safety. That's the big one. Environmental safety. Some of the chemistries, if it's discharged to the environment, it could be quite challenging. It meets all the other requirements. The classic, as we were talking about MRSL, the classic MRSL is an MRSL that was developed by the industry called the Zero Discharge of Hazardous Chemicals, or ZDHC MRSL. And so anything that's bluesign approved is going to meet any and all of those MRSLs, RSLs, because we can do it up front. We're doing it proactively, not reactively. Then the last group system partner we work with is brands. And that's the area that I specialize in and work with. So I get to work with the brands around the world. And I spend a lot of time really in understanding their chemical integrity, their vision as an organization, to the policies they have in place. Spend a lot of time on supply chain and really getting to know their supply network, because most brands do not know their supply network well enough. You can see why, because it's complicated, but need to spend a lot of time doing that. Just knowing the materials, really getting to know the materials in great depth, and not just by trade name, but specifically what's going on there, and what are some of the big chemical issues that are associated with all those different types of materials, how they manage their chemicals, how they actually have chemical management and they bring this through their supply chain, how they engage with their network, how they actually ensure that they have environmental health and safety as a part of their organization, and then goals, progress, and communication. So we spend a lot of time working with the brands to really help them understand not only where they are, the snapshot of where they are, but what are the gaps between where they are and what are some of the common practices and best practices in the industry. And then lastly, we work with them on materials, choosing better materials, choosing a better supply chain, so they can get better materials. And with some brands, we're actually working with them, their manufacturer, and their chemical supplier to proactively engineer better chemistry all the way upstream. But some brands, it's just simply just getting to the place where they really understand what all these impacts are and how they address them. So just looked 2 days ago, we're 727 system partners worldwide. You may know some of these names as chemical suppliers. You probably know a few more of these manufacturers. And this is just a subset of the organizations that are part of the bluesign group and system partners, but I'm sure you'll know most, if not all of these. And this is just, again, a subset of the brands that are part of the bluesign system. And it's great because it is really a who's who of who's addressing these challenges. And some of these organizations are relatively early in their process, and some are quite advanced. So I just have a little bit more to go, and I can stop here and take any questions, or we can just move on through, because we're going to finish up talking about impact. Is there any questions before I move on?
Why don't you keep rolling, Kevin, and then
Okay.
And then we'll do any additional questions at the end. There are some that have come in prior to class as well that we can walk through. So, yep.
Cool. You know, I try to, many of you may have heard this quote before, but it's funny, it's often attributed to David Attenborough, but I'm not sure exactly it is, because it's conflicting data out there, but it's pretty clear. We've got a finite environment, you know, the planet. Anyone who thinks that we can have infinite growth in a finite environment is either a madman or an economist.
We've got a comment in the chat. Those darn economists. I think we may have an economist or two in the in the group.
When we talk about impact, we have various impacts, and impacts are often interrelated to each other. A lot of these are the common impacts we speak of, but many of these are what we refer to as midpoint indicators or midpoint impacts. They're not the final impact of what we really are referring to. And they are, like I said, they're interrelated. You can see that, I mean, energy is, you have to break it down. Is it a mineral, or is it fossil or renewable sources? Those impacts definitely connected to water use, to air emissions. Chemistry is interconnected with most everything in here, when you really boil down to it. But there's really three major impact endpoints that we really refer to. It's human health, that's ecosystem quality, and natural resources. Some people argue that climate change or carbon greenhouse gas emissions are actually another endpoint, but the reality is they are driving everything here, and they're so interconnected. So the reason I cover this here is that we're going to dive a little deeper into climate change for a second, and then actually tie it back into chemistry. So I'm assuming that you've probably seen the classic scope
Yep.
1, scope 2, scope 3. So I don't need to go through
This
over this
is, yeah,
in
this
greater
is the,
detail.
this is the
Where we're
diagram, isn't it? Yep.
yeah. But one of the things that's really important, and you may or may not cover this here, is that 96% of a brand scope, um, um, uh, emissions, total emissions, are in its scope 3. And so, the combination of both upstream and downstream activities, but most of it, in fact, is upstream, and it's in the purchased goods and services. So it's exactly what we have been talking about. It's the network that produces these products. So there are other things. There's commuting. There's capital goods. There's a number of things, but 80% of scope 3 is where most of that impact resides. So we don't know, is it 2%? Is it from a climate perspective, what are the impacts? But what we do know, when we look at this network, we do know where it falls. So even if as a brand it's difficult to calculate your scope 3 impacts, you can very quickly say, where do I focus? Because from an energy perspective, it's tier 2. When you combine both parts of tier 2, nearly 50% of it is falling in tier 2. From a water perspective, it's tier 2. Yes, there's also a fair amount in tier 1 when you include some of the agriculture, and actually leather produces a pretty significant space there as well. But again, you can see where a lot of the concentration of impact may be. And from a climate perspective, absolutely, it's again tier 2. So if you know nothing else about where your impacts are as a brand, you're pretty good if you're focusing on how do you improve your tier 2. So I saw this was in your reading. I will go over it really quickly because I think it's relative to this particular thing, this roadmap to net zero. If you haven't read it, you really should, because it's making some pretty significant plans for the apparel and footwear sector. And that is that we as a sector, in order to keep whatever we are, if we have 2% of the climate impact, we have to really work hard to get to a 45% absolute reduction to keep us on a pathway towards 1.5 degrees warming. This diagram, just if this doesn't just scream at you, it's like I don't know what can, because where we were in 2019 was just about a gigaton. Where we're going is 1.5 gigatons by 2030. Where we need to be is 0.5 gigaton. That is, and so that's what a 45% reduction is going to be. The challenge is how we're going to get there. The report talks a bit about some of the options for material efficiencies and energy efficiencies and a number of different interventions. The challenge is that orange is still, even if we had the best case scenario in addressing these here, we still have that orange gap of where we need to be. And so we're not going to get there doing what we currently are doing. We're absolutely not going to get there. And so how we address this, it's interesting that bottom one, the blue, the shift to 100% renewable electricity in manufacturing, that's not even possible right now, because so much of the impact at tier 2 are coal-fired boilers. And there is not technology yet available to electrify them. And so our challenge is we need to think of better ways to address this. And one of the ways we can do this, actually, it's interesting because there's carbon on the table right now to be had, savings, if we change chemistry. Because we can actually do a lot more with better chemistry. It's not just about reducing toxicity. We can, in many cases, reduce our energy by 30 to 40 to 50% by using better chemistry in the dyeing process. We can obviously reduce the water that is necessary to produce that, and that also gets tied into carbon. So the point here is just simply, we're not going to get to where we need to be by simply just some of the greatest next material. It's a part of the solution, but it's not the whole solution. The other thing we're not going to get there is simply recycling our way out of this problem. If you look at recycling, again, it comes back into tier 4, which is great. So if we eliminate that impact at tier 4, that's fantastic. Okay. But most of the processes that actually have that impact come after tier 4. They happen in tier 2 and in tier 3. Most of the impacts are concentrated there. Also, chemistry is anything but circular. It's actually coming in, most of the chemistry is coming in to tier 2 or tier 3 and sometimes tier 1. And so my point here is that spending the time to really understand that we can do so much more with better chemistry, not just reducing toxicity, but actually reducing our carbon footprint, reducing our water footprint, and many of the other impacts that we have. So I just want to finish with 2030 is barely 2 design cycles away when you look at the outdoor industry's typical design cycle. And we're going to get to 45% reduction in carbon. That's the plan by 2040. So something to think about is what as you continue your career or change your career and be involved in the outdoor industry, be involved in the apparel industry or anything in this space, what's your role in helping this year? Because we need all hands on deck in order to be able to get there. So with that, that's the end of the trail.